Okay, these are the problems. 5-7, the application. Hold on. So these are work problems. Two formulas that we're going to be using is distance equals rate times time. And so you would use any form of that depending on what's given in the problem. So you can have any of those three formulas. The other one is work problem, which is the same as the distance formula, except instead of distance, it's work. Or work, when we say work, it's one job. How long does it take to complete one job? So for this first problem, it says Joe can paint a house in 3 hours. So we have Joe, and we have Sam, who can paint it in 5 hours. So Joe's rate is 3, Sam's is 5. And we want to know how long is it going to take them together. So we have Joe doing a job, one job, and his rate is 3 hours. We have Sam doing a job, his rate is 5. And together they're going to do one job, and we do not know that combined rate. So all we're going to do is solve this problem. This is a rational function because of that x on the bottom. You can either find a common denominator and combine the left side, but I'm going to clear out the denominator by using the common one. So 3 goes into 15x. We have 5x. This would be 3x. This would be 15. I multiplied everything by 15x. So we get 8x equals 15. X is equal to 15 over 8, or it's equal to 1 7/8 hour. So the next one, we have Harry and we have Sally. They, again, are working on a job, one job. They're painting a kitchen alone. Harry, it takes him 7 more hours to paint the kitchen than Sally. Well, we don't know how long Sally's going to take. So Harry would be x plus 7. And we want to know how long does it take. Oh, I'm sorry, together they can complete the same job in 12 hours. So we know that together they can do it in 12 hours. So we have 1 over x plus 7, which is Harry, and we add it to Sally, 1 over x, and we complete that in 12 hours. So common denominator is 12x, x plus 7. This x is not the same as that one. You have to include that. So I'm going to multiply everything by my common denominator, which is 12x, x plus 7. So this, I would get 12x. This would be 12x plus 7. This would be x plus 7. Simplify 12x plus 84, x squared plus 7x. This is a quadratic, so I'm going to move everything to one side. I'm going to keep it on the right side to keep my x squared positive. 24, this would be negative 24. This would be minus 17x minus 84. That factors into x minus 21, x plus 4. My two x's are 21 and negative 4. You cannot have a negative time. That will not work. Sally, it takes her 21 hours. Harry, it takes him 28 hours. Okay? Okay, this has to do with speed or distance. So a car travels 500 in the same time that a train travels 300. So we have a distance, we have a car and we have a train. The car's distance is 500. The train's distance is 300. The speed of the car is 30 miles per hour faster than the speed of the train. So this is the rate. The train is X. The car is X plus 30. Their times are equal. So I'm going to take that formula, distance equals rate times time, solve for T, and I get D over R. I'm going to set those two times equal to each other, the car and the train. So the car would be 500 over X plus 30, and the train is 300 over X. And I'm going to solve it proportionally. So I have this. I'm going to bring the 300 over, divide by 200, and I get X equals 45. That is the speed of the train. The car would be 75 miles per hour. Okay? This is a mixture problem. Sterling silver is an alloy composed of 92.5% silver and 7.5% copper by weight. You have 15 ounces of 800 grade silver, which is 80% silver and 20% copper by weight. How much pure silver should you mix with 800 grade silver to make sterling silver? This is a silver problem. Copper we don't need really in this problem. So right now we have 15 ounces. We want to add some amount that's going to give us sterling silver. Well, we don't know how much we're going to add. And when we get finished with it, the weight of what we have is going to be 15 plus X. Okay, the 15 ounces that we have, 80% is silver. The part that we're going to add to that is 100% silver. We want to add pure silver. So we're going to add this is 100% silver. This is 80% silver. So when we put it in our problem, we have to convert it to a decimal. So that would give you 1. And then what we're trying to get to is sterling silver, which is 92.5%. So it's 0.925. So when I multiply this out, 15 times 0.8 is 12, plus 1x equals 15 times 0.925, 13.875, 0.925x. So I'm going to move the numbers to the right side, so that would be 1.875, and this would be 1 minus 0.925, which is 0.075x. Then I'm going to add or divide 1.875 by 0.075, and x would be equal to 25. So I would need to add 25 ounces of pure silver. Okay, this one, we have a canoe that's going upstream and we have a canoe that's going downstream. So we have upstream and we have downstream. And this has to do with the current. When you have a current problem, or with tailwind and against tailwind, with the current, you have still water. When you get in a body of water and you get in and you don't move, that means the water is still. If there's a current, you are going to move with that current, either it's going to slow you down or it's going to speed you up. If you're going downstream and you're moving with the current, you're going to go faster. So that means that it would be your rate plus the current. Okay, so let me change this and write it like this. Downstream would be your rate plus the current. Upstream would be your rate minus the current, because you're going to go slower. So it says a canoe goes 6 miles upstream in the same water that it takes to travel 10 miles downstream. So we have the distance, we're going to have the rate. So the distance upstream is 6, downstream it's 10, so you can see already that you're faster in downstream. The current is flowing at 1 miles per hour. That's your current speed. What you don't know is your rate. So this upstream would be R minus 1, and this would be R plus 1. So it's the same time. So remember that distance equals rate times time, so time equals D over R. So 6 over R minus 1, 10 over R plus 1. 6R plus 6 equals 10R minus 1. Minus 10. This is 4R equals 16. R equals 4. Okay. You have a helicopter. I'm going to set this problem up because these numbers are going to end up being really large and I don't want to do it. So we have headwind and we have tailwind. So it says that the helicopter flew 15 miles against the headwind. So this is 15 miles against a speed. The headwind is 25. So this is distance, rate. This is still, I put the wrong, no, that's right. The distance is the same. When you're going against the headwind, it is going to be R minus 25, and when you're going with the tailwind, it's R plus 25. And it says that the round trip lasted 27 minutes, so that means going and coming back. So it would be 15 over R minus 25 plus 15 R plus 25 equals total, which is 27. So your common denominator is going to be R minus 25, which is R minus 25 times R plus 25. It's going to end up being R squared minus 625. And we just want to set this up. Okay, this, all you have to do is write an expression. A club at school wants to sell t-shirts for a fundraiser. The club has to pay $4 per shirt plus a base fee of $500. The club will charge $10 per shirt. We want to know the expression that would represent the profit. Okay, we don't have to solve it. It's just the profit statement. Well, if you have to pay $4 per shirt, you are already out negative 4 times the number of shirts you paid for. Plus, you have to pay a base fee. Well, you're already out that $500. You will charge $6 per shirt. Well, that's where you're going to make some money. You're going to make $10 off each shirt. You will not break a profit until this happens right here. You got to sell a lot of t-shirts. And that is how you do that. Alrighty. That's all.